Otters, hope you're all okay. Have been enjoying the beautiful weather today while also staying inside and staying safe, or in your gardens and staying safe. So back to the next instalment of Why is Snot Green? Today the first thing we're going to be looking at is what are Saturn's rings made of, and why don't other planets have them? The rings of Saturn are made of millions of small chunks of ice the size of tennis balls, and other planets, including Neptune, Uranus and Jupiter, actually have rings too. Really? They all have rings too? How come you never see them in pictures? Saturn's rings are easier to see. They're pretty clear to anyone looking at the planet with a half-decent telescope. In fact, Galileo spotted what he called ears on Saturn with his telescope way back in the 17th century, but he couldn't explain them. Almost 50 years later, another physicist and astronomer recognised them as rings around the planet. Saturn has been famous as the ring planet ever since. Even though they couldn't see them directly, astronomers predicted that Neptune and Uranus would have rings in the 1970s. They didn't get a clear picture of them until the Voyager satellite swung by them in the 1980s. On the way there, it spotted rings around Jupiter too, which was a nice surprise. So there are pictures of the rings on other planets. It's just that few people have seen them. Are all those rings made of ice too? Some are ice, some are chunks of dust or rock, and some are probably a mix of all of these. We know that Saturn's, Neptune's and Uranus's rings are made of millions of small chunks of dirty ice, most of them smaller than a tennis ball. Jupiter's single ring seems to be made of tiny dust particles. How did they get there? And why doesn't Earth have them? Small planets and moons don't seem to have rings, so we think only big planets can have them. One idea is that they are formed when a moon gets too close to the planet it orbits. When this happens, tidal forces caused by the pull of the planet's gravity rip the moon apart. The pieces then spread out and encircle the planet, forming a ring that shows where the moon used to orbit. The Earth and the smaller planets aren't big enough to rip their moons apart, so they don't make rings. So why are Saturn's rings the biggest and best then? Well, it's true that Saturn's rings are the most impressive. The pieces are so small and there are so many of them that together they look like a single big icy disk. It would be that Saturn used to have a big icy moon which was smashed into tiny bits when it was hit by a comet or an asteroid. That'd do it. I like that. That's definitely what happened. Is as good as a guess as any. If the Earth's a big ball, why don't we fall off the bottom of it? Because Earth's gravity doesn't make things fall down, it makes things fall towards the middle of the planet. That goes for everything on Earth. Its skies, its oceans and its people. Oh yeah, of course. What? Right, let's go back a bit. Isaac Newton told us how gravity works, like how and why things fall towards the ground when they drop them, and how fast you can expect them to go when you do. Agreed? Suppose so. Okay, well, he also told us that gravity wasn't just about things falling towards the ground, but rather all objects falling towards, or attracting, each other. This force of attraction is stronger for larger objects, and Earth is by far the largest object on, Earth. So everything on the Earth is held on by the Earth's super strong gravity, like a big ball-shaped magnet with bits stuck all over it. Not just metals, but all kinds of things like air, water, trees and people. That's why none of it falls off. Okay, I get that. But magnets work by being magnetic, right? So why does gravity work just because something is big? Well spotted, you're right. There's a bit of the story missing here, so here's the rest. Newton's explanation of gravity was all very clever, and we've since used it to figure out everything from orbiting planets to moon landings. But he still didn't say what gravity actually is. Where did the force come from? Why was it there at all? Newton didn't know, couldn't say. So Albert Einstein bravely had a crack at these and other questions almost 200 years later, saying, more or less, space is not empty or even flat. It's more like a fabric with lumps and dents in it. The lumps and dents are distortions caused by objects, like stars and planets, in the fabric. Gravity is just objects rolling into dents, or around lumps, in that fabric. Okay, I'm having trouble with this one. Okay, try to picture it like this. Imagine space is a big sheet of rubber and the sun as a basketball plonked in the middle. The sheet will bend around the ball, making a dent in it, right? Now imagine rolling a few marbles or tennis balls right across the sheet. Some will go straight across, but ones that pass close to the basketball will get drawn into an arc around it as they dip into the dent. The marbles might even do a complete circle around the basketball before contacting it. So this is why planets circle or orbit the sun. Not just planets, but asteroids and comets too. It's also the reason why moons orbit planets and why satellites and space shuttles can orbit the Earth. Basically, big things make a dent in space and other things roll or fall towards the source of the dent. If they have enough speed and momentum, small things can circle round and round the dent forever. If they don't have enough speed, they fall into the dent and eventually settle next to the object that made it. So planets, comets and asteroids roll around a gravity dent made by the sun. The moon rolls around one made by the Earth. Rockets and satellites get launched to the edge of the gravity dent and roll around it until it's time to come back. And the skies, oceans, deserts, glaciers, trees, animals and people of Earth all sit in the depths of a dent in space created by the planet, stuck to its surface by the force of gravity. Dents in space, eh? Weird. You said it. Next, last question for today. If the Earth spins round once a day, what started its spinning? The suns and planets were formed when bits of a huge spinning dust cloud clumped together to form solid lumps. The Earth, like all the other clumps, has kept on spinning ever since. Let me get this straight. The whole solar system was born from a lump of spinning space dust. Basically, yes, all stars and planets are born this way. Get enough dust in one place at one time and gravity will start pulling things together. When enough dust accumulates, it collapses in on itself, heats up and forms a star. If the dust was rotating beforehand, the star will rotate too and draw other lumps of dust into circuits around it. These circling dust lumps become planets and the star becomes a sun. The sun and the dust lumps round it continue to spin long after they have formed. But wouldn't they slow down after a while? Most spinning things slow down and stop in the end, don't they? That's true. Most things we see every day do stop spinning in the end. But when they do, they don't just stop all by themselves. There's a force that's working against the spin and slowing them down. That force is friction. Let's say you're spinning a coin on a table. From the second you release it, it's constantly being slowed down as it whips around the air around it and scratches against the table below. If you spin that coin while floating in space, however, it would keep spinning forever. There would be no air or table surface to rub against, and so no friction to slow it down. This is what happens when spinning suns and planets. In fact, they even speed up a bit as they are formed. How's that? I don't get that at all. As the spinning sun or planet clumps together, it gets denser but also smaller in size. When this happens, its speed of rotation increases as it's now moving in a tighter circle. You see this happen when Olympic ice skaters do a spin. They start by spinning slowly with their arms wide apart and then pull them in to go faster. Same thing with stars, planets and space dust. Okay, I get it. So the Earth clumped up, shrank up and sped up until it was spinning around once a day then. Not quite. It sped up at first, but then slowed down. In fact, its spin is still slowing down now. Spinning planets and stars can get slowed down a bit by each other's gravity. We call these effects tidal forces. In fact, the moon has been applying a constant tidal force on the Earth, and the Earth upon the moon too, for billions of years now, and this has slowed the spin of the Earth by quite a bit. Thanks to that, the days and nights are getting longer and longer. Brilliant! So every day I can have a longer lie-in and I have more time to see my mates. Well, a bit longer. It's only getting longer by about 2 milliseconds, or thousandths of a second, every century at the moment. Not much of a line, really. I can't wait. Just think, in a few billion years I might get an extra hour in bed. Okay, if you said so. So guys, because this is a non-fiction book, we don't have to read it just from cover to cover, beginning to end. So I would like some feedback from you. So if you would like to, let me start that again. Sorry, there are 1, 2, 3, 4, 5 different sections. There's Lost in Space, which you are currently on, The Angry Planet, Animal Answers, Being Human, and Fantastic Futures. So your first choice is, would you like us to continue in Lost in Space, or would you like us to move on to a different section? I'll tell you the sections again. So we can continue with Lost in Space, or we could do The Angry Planet, Animal Answers, Being Human, or Fantastic Futures. If you would like to continue with Lost in Space, okay, which of these would you like us to do tomorrow? So we've got, will the sun go out one day? Where did the moon come from? Do UFOs exist, and could my maths teacher be an alien? Don't tell Miss Tierney that. What would happen if you farted in a spacesuit? What is a black hole, and what would happen if you fell into one? And could comets on asteroids really blow up the Earth if they hit us, like in the movies? So, email me, let me know, would you like us to continue with Lost in Space? And if so, what questions are you interested in? Or would you like to do The Angry Planet, Animal Answers, Being Human, or Fantastic Futures? Be great to get some feedback from you. I miss talking to you all every day, and yeah, just let me know what you fancy. I hope you have a lovely rest of your day, and I will check in with you tomorrow. Bye bye.